Hello everybody. Today we're going to be taking a look at solving right triangles. So what does it mean to actually solve a right triangle? And then what kind of things do we do in order to make that happen? You're going to need something to write with, obviously your notes and a calculator today. So here's the first thing you need to get in your notes. To solve a right triangle means we're going to determine the measures of all 6 parts. So we need to make sure we know how long each leg is or each side, and then the measures of all the angles. So basically we want to make sure every piece of information there is to know about the triangle, that we know it. We need to make sure that we know it and that we can say what length or angle measurement we're talking about. So we're just going to jump right in and do a couple examples and then we'll be done. You need to copy this example into your notes. This is triangle DEF, and we need to solve the right triangle. And we're going to get some decimal answers here. But to solve the right triangle means we're going to try to find anything that's missing. We need to find it. We need to figure out how many degrees a missing angle is or how long a missing side is. It's our job to find anything that's missing. So as I look at this triangle, the first thing I probably would do is make a list of what it is that's actually missing. So we need to first figure out, let's start with angles here. I have a 25-degree angle there, a 90-degree angle there. I don't know that degrees, so I need to figure out angle E. I'm also going to need to figure out side DF and then side FE. So I have 3 things that are missing on this triangle. One of them's an angle and then the other 2 are sides. And then we're going to do whatever we need to do to figure out those missing pieces. So let's start at the beginning there. Angle E, this angle measurement right here. What would we need to do to figure out angle E? Well, you may be thinking, well, we could set up some kind of trigonometry, sine, cosine, tangent, but remember, let's not forget what we've learned a long, long time ago, that there are 180 degrees in a triangle. And I have a 25-degree angle and a 90-degree angle. So if I add those 2 together, that means I've used 115 total degrees. So out of 180 then, that means I have 65 degrees left. So I know that that angle has to be 65 degrees, and I'm not setting up sine, cosine, or tangent to figure that out. I just know that there are 180 degrees in a triangle. Okay, so we already know that missing angle. Now we need to find those missing sides. DF, I would put an X on that, maybe here, and then we'll go ahead and solve for that side using what we know in our triangle. Now remember, for this we could use Pythagorean theorem, or we could do sine, cosine, tangent. Well, in our case, the only thing that's going to work is sine, cosine, or tangent. We don't have enough for Pythagorean theorem here. So let's pretend we're standing at this given acute angle. X would be adjacent to me, and then 13 is the hypotenuse. So we're going to go ahead and set up a cosine. So I'm going to do cosine 25 equals the adjacent side over the hypotenuse. And then I'll go ahead and type in my calculator what is the cosine of 25. It's 0.9063 equals x over 13. Stick that over 1, cross multiply. And we should end up with x equaling 11.8 approximately, okay? So we know that we have a missing side up there where that x is labeled in my picture of 11.8. So I'm just going to fill that in on my list of things to find here. D to F is 11.8, okay? And then now the last thing on my list of things to find is FE. Well, FE would be this piece over there. I'm going to put a y on him. And we can do the same sort of thing using a sine, cosine, or tangent, sine in this case, to help me find y. Because we're still at the 25, opposite and hypotenuse. We're going to go ahead and set up sine 25 equals opposite over hypotenuse. And we'll use our calculator. Sine of 25 is 0.4226 equals y over 13. Place him over 1, cross multiply, and we end up with y is about 5.5. So I'm going to fill in my missing blank here. F to E is about 5.5. So now we could say what each of the 3 sides are. We have an 11.8, a 5.5, and a 13. And we also know what each angle on that triangle is, a 25, a 90, and a 65-degree angle. So this is what it means to solve a right triangle, to find anything and everything that's missing. Okay, let's do another example. This one's a little different. We're going to solve the right triangle again. And again, we can have decimal answers here. And the very first thing you would want to do after you copy this in your notes is make a list of things that are missing. So what are the pieces that are missing in this triangle that we would need to find? Okay, so that's probably where I would start. Maybe I noticed that angle A does not have any degrees. I noticed that angle B does not have any degrees. There's nothing here, and there's nothing in that corner. And I notice side AC doesn't have anything over there. The other two sides I have information about. So here's what we could do. We could start at the top of that list and try to figure out angle A. So I'm just going to go right here, pretending I'm standing at angle A. Let's look at what I do know in my picture. I do know the side opposite is 10. And I know the hypotenuse of the triangle is 12. And opposite and hypotenuse are both in the ratio sine. So I'm going to set up the sine of angle A equals opposite over hypotenuse. Now, we don't know how many degrees angle A is. We're about to find that out. And that's when we're going to use the sine inverse. So we take the sine inverse of 10 over 12, and that's going to tell me how many degrees angle A is. So make sure that you hit the second button or whatever you need to do on your calculator to make sure you get the inverse sign, and it will tell you that angle A is 56.4. Okay, so we know angle A is 56.4 degrees. Now we could do the same thing to find angle B right here, set up some kind of sine, cosine, or tangent, but I would ask you, if I know two angles in a triangle, do I really have to do that to find the third? No, I can just figure out what that is because I know there are 180 degrees in a triangle. So I'll subtract 90 and 56.4 from 180, and it tells me that there are 33.6 degrees left. Because there are 180 degrees in every triangle, I don't have to set up another ratio to find that. And then last but not least, we can go ahead and find AC. AC you could label with an X over here. We could set up a sine, cosine, or tangent to help us find that. We could even use Pythagorean theorem. I haven't used Pythagorean theorem in a while, so I think I'm going to do that. Because Pythagorean theorem says leg squared plus leg squared equals hypotenuse squared. So it would look something like this. X squared plus 10 squared equals 12 squared. X squared plus 100, 144, subtract 100, and then square root my answer. Square root 44 is about 6.6. So missing side AC is about 6.6. Now if I decided that I didn't want to do Pythagorean theorem and say wanted to do like a sine, cosine, tangent ratio, I would maybe pretend that I'm standing at this angle and this is adjacent to me and I have a hypotenuse, or I have an opposite and adjacent. You could set up a tangent, you could set up a cosine, whatever you want to do, but in the end we should get the same value for A to C. Okay, we should be able to figure that out based on that information we're given, whatever strategy we decide to choose. So this is what it means to solve a right triangle, to find everything that is missing using whatever tool we feel necessary to find that. Okay, so thank you very much for taking good notes. See you later.